Hi class, this is the video of one of the chi-square tests that we'll be doing on the final exam. Let's read through it. 500 people were asked their income level and political affiliation. The table shows the breakdown. At the 0.05 level of significance, test the claim that a political affiliation is independent of income level. There's a couple things here that tells me this is the chi-square test for independence. First, in the claim, we're testing that affiliation is independent of income level. The second thing is that I do have a contingency table to work with. A contingency table has a categorical variable displayed in the rows. Here it's income, and a categorical variable displayed in the columns. Here it's political affiliation. And the number 30 tells us that there were 30 people who were Republican and at the same time earned $50,000 or lower. So this is a contingency table, we call it, and that lets us know, again, that we're working with a chi-square independence test. Now, technically, you wouldn't have to have this table. We could have two columns of 500 values where it might say Republican low, Democrat high, Democrat low, independent low, 500 of these people listed that way, and then StatCrunch could total those for us, but most of the time we're given one of these tables. All right, let's begin. First, the null hypothesis is always of this form. One variable is independent of the other. And here, what we want to think about is which one might be affecting the other. Does your political affiliation affect your income level, or does maybe your income level affect your political affiliation? I think it's more likely that your income would affect your political affiliation. So let's go with that. Here, it doesn't really matter though. We could just say that the two are independent. But I'm going to write it the same way that it was worded in the problem. Political affiliation is independent of income level. And the alternate hypothesis is basically the same thing, except we remove the phrase independent of and replace it with dependent on. So let's abbreviate here. Political affiliation is dependent on income level. So independent, we're assuming that there's no relation between those two. Dependent means that there is a relation between the two. Now, it doesn't mean that it's a clear-cut relation. For example, it doesn't mean that if we know your income level, we know your political affiliation. But if we know your income level and they're related, it may mean that you're more likely to be in this party or less likely to be in that party. There's some relationship there, but it doesn't tell us, this test doesn't tell us what that relation is. It just tells us that they're related. Level of significance given in the problem as 0.05. This is the independence test. Now, we don't have an alternate test for this one. If the expected frequencies in the cell, which StatCrunch will calculate for us, if any of those are below 5, then we have to check to see how many are below 5, or are they all above 1? But here, we're going to end up with clear sailing. I'll show you how that goes in just a second. Let's switch over to StatCrunch, where I've already typed the data in. This is actually probably the hardest part of the problem. You want to type the information in exactly the same form that you see on the sheet. Right? I want to take this table and just take it and place it right into StatCrunch the way that I see it. I did add one thing. I added income as the label for those rows. And the number in the problem, I put only in the first column here. So problem 15 dealt with income and these 3 columns as well. Again, the data sheet I'm working in is called Zoom Final Review, and you can find that inside your StatCrunch group, Woodbury Math 21. All right, to calculate this is also on the difficult side for me to remember because it's not where the others are. This is under Stat Tables, Contingency with Summary. When it says to select the columns, what we have to select are the columns that have the counts underneath them. So that's Republican, Democrat, and Independent, not income. Income does not have any totals underneath it. The row labels, that is income. And what I want to display here is the expected count. If any of those are lower than 5, then I have to worry about the condition. In the MyLab homework, you either also had to ask for the row percent or column percent because you had to fill out those conditional distributions. However, on the exam, you won't have to do that. I've removed that part of the problem. So all we need is the expected count. Press compute. And let me move this over just a bit. First, I want to look at the numbers in the parentheses inside the table. Notice that all of them are much larger than 5, so the conditions are valid. And then I need the test statistic and the p-value. The test statistic is listed under value 76.35, and the p-value less than 0.0001. Basically, that's the lowest result that StatCrunch can give us. I want you to think of it almost like it's 0. Now, we know it's not exactly 0, but it's essentially 0. So back to the worksheet. The test statistic chi-square is 76.35, and the p-value less than 0.0001. Let me switch that out. Okay. Because the p-value is so low, again, basically 0. It's lower than 0.05. That means that we can reject HO. And that means that there is sufficient evidence to support what H1 says. So again, it's not the wording in the problem, it's the wording in H1. There is sufficient evidence to support that political affiliation is dependent on income level. Now, what that means is that we are supporting that there's a relationship between political affiliation and income level. They're related in some way. All right, we'll come back in the next video with another chi-square test, and I'll see you there.